Welcome to day 38, a new kind of equation number 2. So just like the last time, we need to plug our x values into the equation, do the indicated arithmetic to come up with our y's. So if I plug -3 in for x, I have y equals 3 times -3, which is -9, plus 2, which is -7. If I go down and I substitute -2 in for x, my equation becomes y equals 3 times -2, which is -6, plus 2, which is -4. If I plug 0 in for x, I have 3 times 0, which is 0, plus 2, which is +2. Substituting 1 for x, I have 3 times 1, which is 3, plus 2, which is 5. Y equals 3 times 2, well, that's 6, plus 2 is 8. And then substituting in 3 for x, 3 times 3 is 9, plus 2 is 11. So again, when we go to graph, we can create a bunch of x, y ordered pairs. So when we substituted in -3 for x, and we did out the math, we had -7 for y. When we substituted in 2 for x and we did all the math, we got out 8 for y. So those are going to be ordered pairs that we graph. If I move on to the next equation, so y equals 3x minus 1, substituting in -3 for x, I have 3 times -3, which is -9. But this time I'm subtracting 1, so I end up with -10. 3 times -2 was -6, minus 1 more is -7. 3 times 0 is 0, minus 1 is -1. Be careful with that, 0 minus 1. 3 times 1 is 3, minus 1 is 2. Notice we switched over to positive. 3 times 2 is 6, minus 1 is +5. And then 3 times 3 is 9, minus 1 is +8. So this last ordered pair, when we think about going to our graphing, when we substitute in 3 in for x, we ended up getting 8 for y. And last but not least, y equals 3x. So 3 times -3 is -9. We're not adding or subtracting anything. 3 times -2 is -6. 3 times 0 is just 0. 3 times 1 is 3. 3 times 2 is 6. And 3 times 3 is 9. Hopefully you noticed a pattern. And again, when we're looking at our x, y's, when we put in 1 for x and we did the indicated arithmetic, or we ran it through the equation, we get out 3 for y. So that would be one of the ordered pairs when we graph that. Moving to the next slide, I have my graph, and I've already transferred over my ordered pairs. And again, I added in this row because we didn't ever actually substitute in -1 for x, but I put it in the table just to make my graphing a little bit easier. So I'm going to graph the y equals 3x first, since I have my red pen out. So -3. So I'm starting in the middle at the origin, and I'm going left 3, and then I'm going down 9. So that is here in quadrant 3, where both the x and the y are negative. Okay. Then when I go back, I have -2, -6. So left 2 and down 6, still in quadrant 3. Then go back to the origin, left 1, down 3, 0, 0. So I'm actually putting a coordinate at the origin. 1, 3, so right 1 and up 3. So now I'm in quadrant 1, where both the x and the y are positive. And 2, 6, so right 2, up 6. And then lastly, right 3 and up 9. So, and again, if I have a nice steady hand, a little wobbly at first, it should be a nice straight line. So this part of it was not as straight as can be. Let me see if I can make that a little straighter. Okay. All right, so now I'm going to go back to y equals 3x plus 2. So I'm starting at the origin, and I'm going left 3 and down 7. And then back to the origin, left 2, down 4. Back to the origin, left 1, down 1. Remember, that wasn't in your original table. Back to the origin, I'm going left or right, 0, and then up 2. Then I go back to the origin, right 1, up 5. Now I'm back in quadrant 1. Back to the origin, right 2, up 8. Back to the origin, right 3, up 11. That's not quite on our graph, but I'll just estimate one higher than 10 would be 11. All right, so now if I go through and graph, nice straight line-ish. Okay. Oops. A little off at the end. Okay, and I'm going to label this line. So this is y equals 3x plus 2. The red one, I'll go back to my red pen, was y equals 3x. Color coding it helps, but you can also label the end of the line. Notice the lines do have the arrowheads at the end, because you want to show that it's going to continue in each direction to infinity. So you're only showing part of the graph because that's how far our table went. All right, so now I'm going to graph y equals 3x minus 1. So I'm starting at the origin. I'm going left 3, -3, and down 10. Brings me here. And then left 2, down 7. And then left 1, down 4. And these are really, really close to the red line. back at the origin. So I don't go left or right. I just go down 1. Then 1, 2. So right 1, up 2, actually back in quadrant 1. 2, 5. So right 2, up 5. And then right 3, up 8. Okay. So then if I go through and connect those coordinates, I have this line here. Okay, and that is 38B, a new kind of equation number 2. Make sure you ask your teacher if you have any questions.